Hi and hello everyone. Welcome to Skill Inspirational Academy. This is free CCNA Day 12 class. So today we have three topics to discuss. Let me start with ARP. What is ARP and how ARP is used to send packets back and forth between source and destination. And we did a IP phone lab a couple of days back, and we had some problem with the packet tracer, and now it's been sorted out, and I'll show you how the IP phone should be connected to the network and how to assign VLANs. And followed by the DHCP, we learned about DHCP, and we all know how to configure the DHCP server now. You can make a individual and dedicated DHCP server, as well as the routers and switches can also be used as a DHCP, because the services you can run the DHCP services on the routers and switches. This is what we discussed about DHCP so far. So we have an additional concept, that is a DHCP relay, where we have one centralized DHCP server. If you have branch offices, multiple branch offices, and you want one centralized DHCP server, from the management perspective, it's from management perspective, it's always to have one device to manage instead of having multiple devices in the branch office. So that's the ideology of DHCP relay server. So let me start with ARP first. ARP plays vital role in forwarding the packets. Let me start with the theory first, then we'll do a lab session for the ARP. Okay, ARP stands for Address Resolution Protocol. But what is the use of ARP? One thing, this is logical. You got your switches and you got your PCs connected to it, right? And you got a router here. You got another switch. This is switch 1 and this is switch 2. And you got PCs connected to it. And let me make this as a LAN 1 and this is LAN 2. For LAN 1, let me take 10 network /24, and let me take 20 network for LAN 2 /24. So if a PC1 here wants to send a packet to PC1 on the other network, we all know it should go to the gateway, all that, that's fine. But what is the details we got? Two details, right? What is that? This is on 10 network example 10.0.0.2, and this is on 11.0.0.3 example, sorry, 20.0.0.3. This is 20.0.0.3. So when you look at the IP packet, right, if you remember about your OSI and TCP IP model, in the network layer is the third layer, right? So that's the reason we call your router as a L3 device. So it forwards the packets based on the IP address. So I got source IP, destination IP. And have you ever checked your connection? Always your source and destination IP will never change for any kind of communication. It's 20.0.0.3 here. So the source and destination will never change. It's always be the same. So inside the IP packet, to forward this information, I need source IP 10.0.0.2 and destination IP 10.0.0.3. And when it comes to MAC address, that's only local, right? The switch 1 is connected to the router. The router is in the middle. That's connecting two LANs, LAN 1 and LAN 2. Whereas the MAC address that's in the different network, how does this switch know about that? So imagine in the same way, if every switch learns about the MAC address of every LAN, it will be a problem, right? So the design and ideology is the MAC address always stay within the switch, within the LAN. That this cannot be sent across the switch one. The ideology is it should stay within the scope of the local LAN. But anyhow, I want to send a packet, right? So I know source IP, I know destination IP, and I know the source MAC address because the PC1 is sending the packet to PC2. So I know the MAC address. Example, this is AAA of PC1, for example. But I don't know the destination MAC address. That's a question. But how do I send this information back? Because we all know the layer 2 header has source MAC address and destination MAC address. But now in this case, I know my source MAC address, but the destination MAC address is on switch 2. Where is switch 2? The switch 2 is on a different network. But how come this switch 1 know about the MAC address of PC2? That is not possible. But how do I send a packet? Okay. Let me do one more diagram. Now you guys should have understood the packet flow, right? So how this IP packet information, been encapsulated, and what is the information encapsulated in the layer 2 header. Now it would be better for you to understand what is the role of ARP now. Let me clean this. Okay. So now the same topology. This is one router. I got a switch. I got a switch 1 here. I got a switch 2 here. And I got PCs connected. PC1, PC2, PC3, same thing, PC1, PC2, PC3, and I got 10 network here, and I got 20 network here, right? So we all discussed. So I got the source and destination IP. I don't have any problem with that. So inside the network layer, I got this L3 information. Source IP is, as we discussed, that's 10.0.0.2 example, right? And the destination IP address is 20.0.0.2, the IP address of this PC, 20.0.0.2. So I got source IP, I got destination IP. And what is the MAC address of this PC? Let it be AAA. So in the L2 packet, right, I got my source MAC address, source MAC, and the destination MAC, I don't know. So what happens now? So ARP is a broadcast. This is something this PC is saying, hi everyone, I know source IP, I know destination IP, I know source MAC, this is my MAC address, but I don't know the destination MAC address. Who has the MAC address of PC1 on LAN 2? So anybody can help me. It's just something like it's asking for a help to forward this packet. So what happens? ARP is a broadcast. So this broadcast stays within your local LAN because this VLAN is local to this switch. This broadcast will be sent it across to this this specific VLAN if you got the multiple VLAN. But to make it very simple, I made one flat design that by default we all know the switch comes with VLAN 1. So this broadcast to every host in a network, right? So this gateway that's been configured here, this is an L2 device. I have configured the gateway in the router 10.0.0.1. So the PC will get to know, okay, this is in my local network. And anyhow, I cannot reach because nobody is responding back. Okay, gateway take this packet. I don't know where is 20002. It's your duty now to forward this packet, because I don't know that. Because if you want to communicate with a different network, all you have to do is, if it looks for a local LAN PCs, if it can reach, it can reach. Otherwise, it sends back to the gateway. That's the thumb rule, right? So it goes to the gateway. So what happens here? Here you have to focus more about the packet flow. So inside this packet, I got the source MAC address. I don't know the destination MAC address, but this router, this particular interface, every device and every interface has a MAC address, like a device. That is, they call it as a built-in MAC address, BAE. So this interface, example, this is GI 0/0. When I say GI, it's gigabyte port, right? So it might have a MAC address of BBBB. So this information will be encapsulated into layer 2 frame. It puts BBBB. Okay, this is the MAC address of this interface, and this is the gateway. So I'm going to send this packet back to this router. So what is the new encapsulated packet looks like? The source information is 10.0.0.2, and the destination IP address is going to be same 20.0.0.2. But whereas my source MAC address is AAA, but the destination MAC address is BBBB. But what is the actual MAC address of this PC? Let it be CCC. Guys, this is for example. I'm saying the MAC address looks different. To make it simple, I'm just using 3 characters here. AAA and BBB. This is the new encapsulated packet. Now this router receives this packet, right? So what happens next? Again, the same process. Now the router, what it does from the router's perspective, it will check inside the routing table, and it know about the directly connected devices. This is something you are inside your house and you know where your living room and where is your bedroom and all that. So you know about all the information. The same way, this is directly connected. It is aware about the switch 1 and switch 2 and the networks configured on it, because I have configured both the gateways in the router. One is 10.0.0.1 and one is 20.0.0.1. So this gateway that is inside the routing table. The lab I'll show you, you guys might know about this routing table, aware about this. I believe this, you guys might be aware about this because this is a day 12 class. But anyhow, I'll show you the routing table again. So inside the routing table, I am aware about 10 and 20 networks. So what happens now? Let me redraw this because this is too clumsy. Now you guys understood, right? The very first packet, you have to remember that. Okay. So again, the same topology. Router, and I got a switch. Let me put only one PC. This is AAA, and the PC here in the network is CCC, and the gateway is GI 0/0, and one more gateway is GI 0/1, for example. And this is configured with gateway 10.0.0.1, and this is on, I said it's 12.0.0.1. This is a gateway for LAN 2. This is a gateway for LAN 1. And this is switch 1 and this is switch 2. So the information what I got here till this point, this is BBB, the MAC address, right? So now what happens? Again, ARP request. It's a broadcast. So what is the information it got now? It's going to change the address. So what, since this is we know this IP address is 10.0.0.2. That's never going to change here. So it's 10.0.0.2. It's the source IP, and the destination IP is 12.0.0.2. I know 12.0.0.2. And what is the MAC address now? See, the MAC address of this interface where the gateway configured for 12 network, 12.0.0.1. Let it make it as DDDD. So what is the source MAC address it puts inside? DDD. Even though it's directly connected, it's the job of the switch is to, it works on layer 2. The router is again a layer 3 device. It is not aware about that. So what it does, it doesn't know the MAC address, right? So all F, it's a layer 2 broadcast. Again, the router is saying, hey, I know the IP address of this PC1 on LAN 2, but I don't know the MAC address. Help me with that. What is the MAC address of this? For this ARP request, this PC would say, hey, I am 12002 and this is my MAC address. CCCC. And you update the information for your ARP request. I'm sending back the ARP reply. This is important. From the ARP request, I get to know the IP address of the router. MAC address of the router. When I say the MAC address of the router is the interface address, this interface. I know the MAC address, I know the IP address. So I'm not going to do a broadcast. I'll send this back to you because I received the ARP request from you. So I'm going to send an ARP reply back. This is Unicast. This is important. It's an interview question. ARP request is a broadcast. ARP reply is a unicast. So now this packet comes back to this PC. So this process will happen only once between the source and destination. So you might all have seen the ARP details inside your command prompt. If you give ARP-A, it will show the IP address associated with the MAC address, right? Let me show you that. Can you see this? This is the ARP request. For my ARP request, I got this ARP replies, right? So this is all one key thing here. This is only the local. This is my local broadband network. So this is my gateway. 192.168.0.1. This is my gateway. So it got the MAC address of the gateway, B7CE, through ARP request. Don't bother about this. This is all, the public IP address. We don't want to concentrate about that. For the beginning, just concentrate on the local LAN, how this broadcast happens. Can you see this? This is layer 2 broadcast. All Fs. So all the LAN network will respond back to this ARP request. One side, only your local LAN networks. So this process goes on until it reaches the destination. One hop to the router, then from the router to the PC. Since this is a small network, the ARP process looks pretty simple. But in the big network, it will go all the way back until it reaches the destination. But this is the ideology about the ARP. So now let's do a lab for ARP. The same topology what we discussed there, I'll do it as a lab. I have one router. I got a switch, 2 switches. And then I got a PC. I'll take 2 PCs for testing. Here I got 2 more PCs. I'll make a connection. Okay. Let me zoom in a little bit. Let me go inside the router. I'm going to create gateways now. Interface GI 0/0, IP address 10.0.1, default subnet mask 255.0.0.0, and then no shutdown. The router port, you have to manually bounce the port, whereas the switch port are auto negotiable port. It does an auto negotiation, whereas the router, it won't do an auto negotiation. So I'll go back to interface GI 0/1, IP address 20.0.0.1, default subnet mask value, class A, no shutdown, created 2 gateways. So I'm going to keep only one network here. VLAN 1, both. So let me do this. This is 10 network. This is 20 network. So the gateway configured is 10.0.0.1. And the gateway configured is 20.0.0.1 for this interface. So what is the IP address I'm going to assign for this PC? It's 10.0.0.2. And here it's 10.0.0. Sorry. 20.0.0.2. So what is the gateway of this PC? 20.0.0.1 gateway. What is the gateway of this PC? 10.0.0.1 gateway. What is the subnet mask? 255.0.0.0. And this is a subnet mask of this PC. Done. Okay, we'll go inside the router switches and let me see the ports. I'm going to clear this. Show MAC address table to see the MAC address that's being learned inside the switch. And I see only one MAC address. That's on fast Ethernet 0/1. Let's see what happens now. Let me go to the PC. I'm going to assign an IP address here. 10.0.0.2. Default subnet mask value and the gateway. No DNS at this moment, just a gateway subnet mask and the valid IP address in the same range. Go to PC2, static IP address 10.0.0.3, default subnet mask, and I should have the gateway. If I miss to configure the gateway, the PC1 and PC0 and PC1 will communicate. If anybody know answers, you can write the answers on the chat. If both PCs on the same network, if I haven't configured the gateway, will the PCs communicate with each other? Your answers are most welcome. You can post your answers in the chat. Okay, now I have assigned IP address on PC0 and PC1, and let me go to switch 2. Assign an IP address from 20 network. 20.0.0.3 default subnet mask, and the gateway is 20.0.0.1. Done. No DNS at this moment. I'm going to the second PC, sending an IP address 20.0.0.5, default subnet mask, and the gateway is 20.0.0.1. Done. So let me show this ARP table now. Show IP ARP. I can see the ARP entry only for the gateways, not for the PCs, because this PC1, any PC here, this topology, haven't sent any packets back and forth. So the ARP process happens only if a PC0 tries to communicate to PC2. Any PC has to communicate first. It has to send the ICMP probe. Only then the ARP cache will be updated eventually. So now the PC0 didn't send even a single packet out. So there is no ARP entry for that. But this is all directly connected. This gateway, it shows the MAC address of its own. So let's see what happens now. So this is 20.003 and this is 10.002. So let me go and open a command prompt in this PC and do ping. Let me do a real time. I mean, it will capture the ARP packets. Let me check the filters. Do we have ARP entry here? ACLs, it should be an ARP here. SSH, FTP, TCP, ARP, press ARP. There should be an ARP here. Show all ICMP RIP. Okay, I think it's not enabled. Okay, I have included the ARP now. Only ARP. Okay. So let me go now and do a ping to 20.003. So it's capturing the packets. So what happens now? The PC sends a packet to the switch. There's a layer 2 broadcast that goes to gateway, right? For the ARP request, it sends the ARP reply back and it goes to the PC. And now this packet will be sent back to this router. Then let's check the ARP table now. Show IP ARP. Earlier, I don't see ARP entry for other devices. Now I see the ARP entry for 10.002. I learned the MAC address, and this ARP for this ARP request till it's incomplete. So that's the reason I think the packet is not forwarded back to the PC. It got stuck. Let me stop this. Come to real time. Let's see. Okay. Now I can ping. Go to simulation. Do ARP capture. Let me see if I see the ARP entry for, okay. So now I see the ARP entry for 20.003. I learned this MAC address through ARP request. So what happened exactly? So now, as we discussed, it sent a broadcast, layer 2 broadcast, and other details we know, right? For the L2 address, the MAC address of this PC, AAA example, and the destination is F, all F. For this broadcast, ARP request, this router sends an ARP reply back. This is Unicast. Why? Because it know about the MAC address, IP address, and all these details from this ARP request. Since I know where the ARP request came from, this router is going to send back the ARP reply. It's an unicast to the intended destination, not for everyone. That's the reason this is unicast. I don't know the command. It works in the the same command the Windows command. Okay, it just shows 10.0.0.1, just the gateway, right? This is intended because this PC, no, this PC is aware, and the limitation of this PC is only between the scope, because this PC belongs to this network, 10 network, not the 20 network. So it is not aware of 20 networks. So the ARP entry, whatever you got, it gets the ARP detail only for this local LAN. If you go back to this PC, it doesn't know the MAC address of 10 network. It is only aware of 20 network, right? Because as I told you, ARP broadcast, that's actually stop here. From LAN 1, it goes till here. For LAN 2, it goes till here. Imagine if this ARP broadcast is forwarded across, the whole internet router will be in a loop. Whole thing is broadcasted. All the router CPU utilization goes high. So that's not the ideology. That stops here right away. So you might have a question, then the router is sending an ARP request. That's an ARP request, not for everyone, right? This sends an ARP request, but only the device, the next hop will respond back. It's not that this ARP request broadcasted back to every host in the network. This is limited because this is on 20 network. This is going to send a broadcast back with its MAC address to this network only, not the other network. This is a little bit more for today, but anyhow, my intention is, to give you the best about the ARP understanding. You can go through, many documents. You'll get to know the same thing what we discussed, but I have to give you more visual about how this exact ARP process happens. So if a second PC, for example, if this PC wants to communicate to the same, vice versa will do now. From this 20 network, I'm trying to reach 10 network, 10.0.0.3. Let me turn on the simulation and ping 10.0.0.3. I'm trying to capture some out packets here. Okay, so here I got an ARP reply. Guys, can you see this? This is what I want to show you exactly. If you see this ARP, as I told you, this is layer 2 broadcast. So what is the IP address? This is a target IP 20.0.0.1, and this is a source MAC address of this PC 20.0.0. What is the source IP? 20.0.0.5 IP address of this PC. So in the source IP, it puts the IP address of its own, and target MAC, since I don't know the MAC address, it sends a broadcast out to all the hosts in the local LAN. And this gateway, this router is connected on the same network. It receives this broadcast, right? Let me open up one more packet capture. So can you see this? This is layer 2 header. We got source MAC, destination MAC, and ARP request for 10.0.0.3. See, it is sending back to the gateway. Same way, vice versa here. See, this is source MAC. This is target IP, source IP. This is sending back to the gateway. This is ARP reply. Once it receives an ARP reply, only then it can send this information back. Guys, for theory and understanding, you'll definitely get it when only maybe half of the concept. I would recommend you to do a lab. Only then you can see the packet capture. With the packet capture, you will exactly understand what is the source IP and destination IP and why it's doing a broadcast and what is ARP reply and why I'm saying it's an unicast, because I see only the source IP and destination IP, source MAC and destination MAC. Because from this, I can say this is an ARP reply. ARP reply is a unicast. Say 10.0.0.3, it's sending back to 10.0.0.1 after it received an ARP reply back from the router, because it know where it came from, so it will send back accordingly. That's it about the ARP, address resolution protocol. Without this, no communication happens in the internet. ARP is very very important topic you should definitely be aware of. Let's move on with the other topic. So we discussed about ARP lab and theory. Let me do a DHCP relay. I'll do a quick recap about DHCP relay. Theory, not much, because we discussed about DHCP relay. We had a theory, a quick recap. Let me use this. So what I'm going to do, I'm going to use a router with two switches, LAN 1, LAN 2. So the LAN 1 has a dedicated DHCP server, right? This LAN 2 doesn't have a DHCP server at all. But this gets an IP address from this DHCP using a concept called DHCP relay. So this is like very simple example, as it you have some problem, okay? You both are friends and you want something to get from the shop. It can be anything, right? You cannot go to the shop, but you know the shop. You are saying your friend, hey, help me, I want this, go and get a chocolate for me. I know the store, but I cannot come there because I borrowed some money. He will definitely catch me if I go there, but get something from there. You'll just give this instruction and you'll give the store details. So what happens? This guy goes back to the shop and gets a chocolate and give it back to you. So your purpose is fulfilled here. In the same way, this DHCP relay, inside the DHCP relay, I'm going to, like the store information, I'm going to give the DHCP IP address detail here. So what happens? I don't have an IP address. Hey, relay agent, can you help me to get this IP address? So this information will be sent it across as a unicast, not a broadcast. Because manually, I hard code this DHCP server detail. Manually, I'm sending this back because I hard coded this IP. And the IP address will be, I got the IP address and the reply comes back to the same source. As I told you, I tried to explain you simpler. I hope you guys would have understood that. To make it simple, that's it about DHCP relay. So let me do a lab, you'll understand better. Guys, give me a second, yeah. Sorry guys, I got some power issue here. Okay, so let's do a lab now. I got a router and 2 switches. Let me quickly do this. 2 PCs. So my intention is this PC4 has to get an IP address from this switch. This switch works as a DHCP server here. Let me do a quick connection. So go back to the router and bounce the ports. Interface GI 0/0, no shutdown. And IP address. Okay, IP address is 10.0.0.1.255.0.0.0. No shutdown. I keep no shutdown, right? Okay. Come back to real time. And interface GI 0/1. First bound support, layer 1 connection is up. Going to assign an IP address, bring it center 20.0.0.1 255.0.0.0. No shutdown. This is done. How do I verify this? Let me give show IP interface brief. Okay, so I see both my status and protocol should be up. Only then the ports are operational, functional. So this is negotiating. So let's do a quick DHCP configuration. Maybe I'll do it in the switches. If I want to do inside a switch, it should be on the same VLAN, should be on a trunk. Let me do in the router. IP DHCP pool, and I create a pool for 20 network. Okay. 20.0.0.0.1. No. Let me try to do in a different way. Let me try to do it here. Let me keep one more server here, DHCP. Go to this server, go to services, DHCP, enable the service, and check your port is fast Ethernet 0. It is connected, that's fine. I'm going to give a custom name, going to give Skilled Inspirational Academy, CR, and the gateway is going to be 20.0.0.1, DNS 20.0.0.1, starting IP is 20.0.0, okay, 20.0.0.10. Subnet mask is default subnet mask. Let me add the scope. Done. Services on. Fine. Everything's done. Let me verify the subnet mask here. Show run. Okay, the subnet mask is fine. So what's my intention now? So this 10 network doesn't have an DHCP server now. So I'm going to, this should be configured in your gateway. That's important. I'll tell you why. Interface GI 0/0 IP helper address. Okay, this is the command. Hey, help me give me an IP, give an IP address. I am not running the DHCP server, something like that. So that what is the destination DHCP address? So I'm going to assign an IP address in the same network. 20.0.0.25 default subnet mask. Gateway is going to be 20.0.0.1. Okay, close this. So what is the IP address I should give here? 20.00.25. Done. So the DHCP scope is on. I have configured a DHCP server here. And this is 20.0.0.5, and I have given inside this interface. This is important. See, this is the gateway for 10 network, right? 10.0.0.1. I have assigned an IP address 10.0.0.1. But inside this interface, I have configured IP helper, what it does. So this for this discover, DHCP discover, right? Let me take my digital pen here. For this DHCP discover from 10.0.0x, any network, it reaches to the gateway, and inside this gateway I have configured IP helper, right? So this will be relayed back because I've configured say 20.0.0.25. There is a release back to the server, and for this discover, it sends a reply back to this gateway. From this gateway, the packet will be forwarded back again to this PC, and this PC should get an IP address. That's the objective. Let's try. So I didn't assign an IP address here. Let me request an IP address. DHCP failed. HappyPaw is being used. Why is that? Let me try one more time. So here comes troubleshooting. Why I didn't get an IP address. So for that, let me try testing with static. Let me reach the gateway. Let me make it as 25. Just for testing. Is it the PC is communicating back to the gateway? So I've assigned a static IP address, and let me try 10.0.0.1. Okay, I can ping. So my DHCP has problem. I think this has some problem always with, what is the DHCP pool here? Services, DHCP. And I got my gateway, right? 20.0.0.1, this is my gateway. This is DNS server, and the IP address is 20.0.0.10, and this is the default subnet mask value. Everything is fine, but this is not relaying this back again. So what you have to do here, do a debug DHCP. You cannot do a debug here for DHCP. Packet tracer is limited then. Okay, what is this? Is the scope. Let me try for this PC first. The DHCP is functional. So this is how you have to drill down. See, from this local LAN, I'm trying to reach this DHCP server. Do a DHCP discover to check is it functional. So my DHCP server is working. So my IP helper address might have a problem. So what is that? Let me go and check. Show run. So I've configured IP helper, and I gave it as 20.0.0.25. So the router to reach 20.0.0.25. So let me try with the router. Do I reach 20.0.0.25 here? Sorry, hang on for a minute. I think this DNS resolution will happen now. We have to wait. This is it should go back to 20.0.0.25. Let me try to ping that first. So let me try to, this is all directly connected. Do I need a route? No. So let me try to ping 20.0.0.1. I can ping. Let me try to ping 20.0.0.25. I can ping, but the DHCP request is not going back to the server. Close this, open this back. Control-Shift-6. Okay. So to ignore this problem, you can give no IP domain lookup, because you know what happens. This is trying to do a DNS resolution. Domain server, it does a broadcast, so it's querying back for the DNS. You can disable that giving a command no IP domain lookup. So let me ping 20.0.0.25. I can ping. Okay, I know where could be the problem. It's because we have configured a static IP here. Okay, this is a DHCP server. Sorry for that. 20.0.0.25. Default gateway is 20.0.0.1. I have to go back to this PC. So this is a problem. See, this DHCP server is not giving the gateway. Got it? So this is not, I mean, this cannot reach the gateway. Let me delete this and do, I'll add a, I mean, make it a switch as a DHCP server here. Let's having problem with this DHCP server. So better, let me make this switch as a DHCP. IP DHCP pool. Let me give SIA, Skill Inspiration Academy, and network for 10 network. I'm going to create for 10 network. Default subnet mask and your default gateway 10.0.0.1. Right? That's it. So I'm going to test this now. This is on 10 network. This is on 20 network. I hardly suspect this will work. IP fails. Expected. So let me try to reach this server first. So I've created in the 10 network, and this PC is trying to communicate to, let me try the PC can ping 20 network. Zero 25 and 001. So IP address of this PC 20.0.0.2. Cannot ping. Why is that? So directly connected. 10.0.0.25. Okay. Let me do one thing. Don't worry about this. I'll explain about this routing protocols later. Let me try to build this lab first. So network is going to be my 10.0.0.0. The wildcard mask. It's for a wildcard mask. Just enter network 20.0.0.0. My intention is this PC has to communicate back. This PC is assigned with IP address 20.0.0.2. So it's not getting a gateway here. It's a problem. I haven't configured a DHCP server yet for 20 network. Let me give 25 20.0.0.1. Okay, can ping 20.0.0.25. Then now I should get a DHCP now. Okay, let me create one more interface. VLAN 2 IP address 0040 0. So let me make this port as VLAN 2 then. Interface fast Ethernet 0/2. Switch port access VLAN 2. Going back to this port 0/1. Switch port mode trunk. Got my L2 VLANs. Guys, I think you guys are aware about this VLAN, so that's the reason I didn't explain all this. Physical and CLI. Okay, this has been assigned. And if I give show interface trunk, so this is trunking and native VLAN is 1, the allowed VLAN is 1 and 2. Okay, expected. So it's negotiating. Now let me try. So my DHCP is failing, it's not going back. So what is inside that switch? Okay, I got this gateway. We had the same problem with the packet tracer for VLANs, I remember. So my DHCP is failing, it's not going back to the switch. This is how you have to do troubleshooting, right? Irrespective of your results, you have to find how to make it reachable and why it's not working. So let me check. The VLANs are up, ports are up, but still my DHCP is failing. Let me go back and assign a static IP again, 10.0.0.45 default subnet mask and 10.0.0.1. We try to reach this IP address 20.0.0.40. I'm in real time, right? I got a gateway configured. I'm getting a reply back now. Seems to be I'm getting a reply back. No. 20 timeout. Okay. So what should I do now? Freeze route to find where it exactly the traffic is dropped. Trace route not works here. Tracer T. Very limited function. Okay, tracer T command. So it can reach only the gateway, right? So this first gateway sends 3 popes and it reaches the gateway, but not the 20 network. Request timed out. This is something problem with the routing. So this is directly connected, should not be a big challenge. So what is the command I should give? Show IP route And I know about 20 network, and I know about the gateway, and I know about 20 network. So from this PC, can I ping the gateway configured on the switch? I cannot ping 20.00.40. That is the IP address of this VLAN, right? 25, okay, 255.0.0.0. And I enabled in the trunk. And what else that's allowed inside? 20.00.40. Can I give show IPR? So it's not learning the ARP. Show CDP neighbor. Okay. So I got this interface. Okay, show run. What is the configuration inside the gigabyte 0/1? This is 20.0.0.1. Okay, let me ping 20.0.0.40. Source command is not working here. So there's a problem. I cannot reach the switch being in the same network. Is it a bug from the switch? I'll try to reach the router, all the possibilities. So 20.0.0.1 ping 20.0.0.1. Okay, I know what the problem is. Let me delete this switch. Let me add a layer 3 switch. I think the packet tracer, they make this L3 switch only the L3 switch can understand. Switch. Only I got, okay, I should have a layer 3 switch, right? So layer 3 switch, 3560. So connect this back. Any specific commands to run for routing? So IP route. Okay, got it. So interface fast Ethernet 0/1 IP address switch port mode trunk interface VLAN 2 IP address 20.0.0.50 255.0.0.0. So VLAN 2 L2 VLANs creating L2 VLAN 2 VLAN 2 is up, and let me try if I can ping from this to this PC 20.0.0.25. Ping 20.0.0.25. Being in the same network. Okay, let me do a port configuration for this. Is fast Ethernet 0/2. This port access VLAN 2. So I think my L3 interface is not up then. Show IP interface brief 20.0.0.5. So from here now, let me try to ping both ways to the router, head end router, and the PC. How come I made it as a trunk and I got a gateway there? Okay. configure gateway, IP gateway. There should be a command for a gateway. IP default gateway. .0.0.1. Not needed. I have a trunk. Show interface trunk. Interface fast Ethernet 0/1. Switch port mode trunk. Trunk host trunk encapsulation auto. Okay, so I have to give switch mode trunk encapsulation .1q. We learned that this before, right? Switch mode trunk old switch port mode trunk. So status up, it's negotiating. Let me try now to ping. To give some time for negotiation. Okay, let me try the down access port 20.0.0.25. Okay, and ping now. So let me try to ping 1. Why I cannot ping? Have a trunk. Show IP interface brief. It's up. What is the ARP it shows? Show IP ARP. Learned about the ARP, right? So it learns about the gateway, but the gateway. Okay. This GI0. Let me do a little bit of modification. No IP address. Then I'm going to create a sub interface .1 encapsulation .1q2 IP address 20.0.0.1. Done. So IP interface brief. This is up. Let me try my layer 3 packets are going back. Let me try to ping the switch. Okay, now I can ping. Let me create a DHCP pool. Sia, and then network is 10.0.0.0. And then, so this is for 10 network, right? Let me try to put it here. Let me create, that would be better. So interface GI 0/0, no IP address, then .1 IP address before that, encapsulation .1q VLAN. Let's make it as VLAN 10. So inside the switch, let me go to create L2 VLAN 10 and the interface fast Ethernet 0/2. Fast Ethernet 0/2. With port access VLAN 10 done. And interface fast Ethernet 0/1. Switch port mode trunk, and let me check the ports are negotiating, show VLAN, and the VLAN 10 is assigned for 2, right? So this is on VLAN 10, and the gateway has been configured here. IP address 10.0.0.1 255.0.0.0. Packet reset deployment, you have to be a little bit different from the real world. So 20 and 10 network both are up, on the IP address are up and running. So now let me try to get an IP address now. So CR says 255.0.0.0, default router 10.0.0.1, right? So let me try to ping this IP address now, 20.0.0.25. Okay, I get a reply back. So it should get a IP address now. Go back to the PC. Still failing. So this relay command is not working then. Okay, go back to, let me do a relay from the router. Let me try. So this is, okay, from this network, I'm going to relay this back to 20 network because my switch is on 20 network. So IP interface brief. Okay, here is my VLAN 2. It should definitely get, why is this? Okay, interface GI0/0.1, right? .20.0.0. Where's my helper is on 20.0.0.1. What is that? My DHCP server. It's on 20.0.0.1. So run. Let me check my DHCP scope. So I'm going to create a DHCP scope here. DHCP pool SIA network 10.0.0.0 255.0.0.0. Default router 10.0.0.1. So various IP helper address I have to configure inside this interface. So run, created a DHCP pool, and I'm going to call the DHCP server from. Let me try to do a relay inside the same subnet first. Okay, it gets an IP address in the same subnet, so it means my relay is working. So my intention is I have to get an IP address from 20 network, right? But here, where is this show run? This is my 10 network. So let me delete this and try. And now I'm trying to figure out I have two scopes. Okay, I got scope in the switch as well as in the router. So now I'm trying to find, seems to be it got an IP address from the router, right? This helper address is working. The complete functionalities to making it into two different subnet. That's my intention. Here I have created an helper within the same subnet. I'll try with this EVNG lab the next class, but now the IP helper seems to be working, but it's picking this helper. So my intention, it has to get an IP address from the switch from here, because this subnet, for this 10 subnet, I have configured the DHCP pool in the layer 3 switch here. But anyhow, the relay is not happening, but the routing works. Maybe we have to check, is that any limitation with the packet trace is actually blocking this DHCP relay. I'll check on this part, and maybe the next class, if we cannot achieve this in the packet tracer, I'll do it in the EVNG lab. Yep. And that's it for today, guys. I think today we got, little more time. We have taken time, just because of, I think it's because of a packet tracer, because you guys have seen the helper address is working fine, but this limitation, I got my trunk and everything, but still I have to figure out here. I try to figure out, but now it seems to be a little tough here. So I'll check this from the packet tracer perspective. Is there any limitation is blocking is, because this is not fully functional like a real device. So I believe the EVNG lab would be better for this. It's only for a layer 2 broadcast, right? If you enable layer 3, then two LANs can communicate, right? I mean, the ARP can work for L3 also, right? ARP is a different protocol, and ARP is a different protocol. What is the question here? Just a quick query. It is only for layer 2 broadcast, right? You mean ARP? Let me unmute you, participants. Okay, you can unmute yourself. Who raised this question? DA5A7491. Just a quick query. It is only for layer 2 broadcast. What is that layer 2 broadcast? Hello, you are there? DA5A7491, because I don't know your name, sorry. You there, sir? Hello?
Yeah, hi. Sorry for the delay.
Okay.
Just a, so my question is like, we enabled, layer 2 is a broadcast, right? For ARP.
No. A quick clarification here. Broadcast is common. It's
yes,
not specific to layer 2 and layer 3. Broadcast is common. That's for everyone. So
yeah.
the broadcast can be classified into layer 2 broadcast and layer 3 broadcast. So layer 2 broadcast is MAC broad. So it all F, because it does a layer 2 broadcast. It means only for the layer 2 protocols, right? With the MAC. So it gets try to find all the connected MAC address in the layer 2 broadcast. In the layer 3, it tries to find all the local LAN network. It sends the broadcast for the whole network based on the IP address. So for this broadcast, an IP address, I will get a response from an IP address. That's layer 3 broadcast. For the layer 2 broadcast, if I do a layer 2 broadcast, I get an expected MAC address for this layer 2 broadcast. So that's the key difference between layer 2 broadcast and layer 3 broadcast. Broadcast is a one generic term that can be used for layer 2 and layer 3, and that is common for ARP. Wherever it's a broadcast, it's for everyone. ARP is a different protocol. I mean, ARP can work for layer 3 also, right? ARP is entirely different. See, this is all like your headers. See, L2 is a separate header. L3 is a separate header. Inside the L2 header, you got your source MAC and destination MAC. And in the L3 header, you got your source IP and destination IP. And the ARP is a different header. So you got your IP address and MAC address together. So sometimes they call it as layer 2.5 because it got both IP and MAC, right? If you give show IPR, it gives the IP address, right, mapped with the MAC address. So you get both information in the ARP. I mean, is that I'm sorry that if I didn't understand your question. I believe this is your question, right?
Yes, correct.
Oh, okay, fine. You got it?
Yes, got it.
Okay, fine, no problem. Okay, guys, I think this IP helper today, it works partially, I would say. So I'll come up with a lab in the EVNG that would be better. Yeah, we'll do this lab, redo this lab, because we have to make it working as we intended. Okay, guys, if there is no further questions, let's close this session for today. Do this lab. I mean, you should also, struggle with the lab. I would say, I mean, only then you get the concept. Just for looking at the lab, just like a mathematics, just looking at because I experienced this when the max class, when they do that, we feel like, okay, I got this, okay, this is working. But when we do, we get problem. That's where, because in the real world, the same thing happens for you. If you have problem, the same way, do it. Go check, hey, is this a layer 2 issue? Is this a layer 3 issue? Is this a VLAN assignment? Is a gateway? Go through all that. So it becomes like your mind mapping. You'll go step by step. I have to check IP assignment. I have to check the port configuration. I have to check the VLANs. I have to check the trunk. So that's how I do, and it helps a lot so far. So I always suggest you guys to do lab as much as lab. Even it is successful, if you're getting problem, if you're not making it, that's not a problem, but you'll understand, you'll get better and better. So I always suggest everyone to do a lab. That's my humble request for everyone. Practice lab. Yeah, somebody he raised I mean, who's that? Sorry.
It's my Vishnu Chakravarti, sir.
Sorry, well, your voice is low.
Sir, Vishnu Chakravarti.
Yeah, Vishnu.
So only I joined this class.
Okay.
I need previous videos.
I'll discuss with my internal team. Okay, so I'll check with that. Is there any possibility?
So also today's video, I need today's video also.
Sorry?
I need today's video also.
Today's video is recorded, sir. You will get the videos.
Yeah. Okay, sir.
Okay.
Good evening, sir. I have a little request to team management. Kindly give the rights to type the message in the groups on class times.
No, I think chatting is people, they are chatting to me. I mean, I believe it's not blocked. Is it you cannot do it?
No, it's blocked. Only admin can type the message in the group.
No. If you actually see, this is all the messages I got from the participants. I didn't type this.
Which kind of message?
The messages, can you see? Maybe, I don't know, sir. Can you see my screen?
In chat engine?
Yeah.
In Zoom, na?
Sorry?
In Zoom ID?
Yeah, Zoom ID, yeah.
No. I'm telling about the WhatsApp group.
I think, see, somebody, they post answers. I don't know that. I have to check with my team about that. You're talking about WhatsApp chat?
Yeah, exactly.
Okay.
Not for whole days, only in between the classes. That's it.
Okay.
Any query, if any messages occurs in our mind, then we can type them that particular.
I think they open it for some period of time, I believe, right? They open.
Yes, on only for class time. And after 15 minutes, you can do that. You can block that particular.
Okay, I'll talk to the internal team then, because I don't know
on that time when you are making some lab, na, on that time we have we basically we want to type the questions and answer on that time on particular topic, and after some time your topic is passes away and we forgot that particular questions.
No, we got a Q&A session on, I mean, even that's limited to Wednesday and Friday, but I am making more Q&A sessions to make it more interactive. But anyhow, I'll check with that. If there is any possibility, then we'll try that. But we have some policies. I have to check with that because I cannot give
Right.
any
No,
confirmation on that. Yeah.
it's only for request, not compulsory.
Okay. I'll talk to them and
Okay.
I'll try to, I mean, I'll give you an answer on that. Yeah.
Okay, sir. Thank you.
No problem. So guys, I can further take up this as no questions anymore. Let's wind up this class. If you guys have any questions, you can ask. Otherwise, I'm going to close this.
Sorry, I saw the message on when you are showing the ARP table in system. On that time, one words are type dynamic. Can you show again that particular message?
Which one? This
Uh,
one.
uh,
This one.
this one, yes.
Dynamic is
It's IP. It's for IP or it's for the physical address?
no. That is for the MAC address.
MAC address. Is it possible dynamic MAC address?
No. I'll tell you. See, for this IP.
Yeah, exactly.
This is your MAC address, right? This is your MAC address. You can assign any IP address to your PC. Think from a PC perspective. This is the MAC address of my PC. I can assign any IP address. So that is dynamic. I mean, this IP address is dynamic to this MAC. It can change.
This type is showing for the IP addresses, right?
That's your question. Dynamic type, yes, dynamic.
Yeah.
So as I should say, it's together. It's together. Okay, this ARP entry is dynamic. It can change. But this is not one specific to, if you ask me a question, if it is specific to IP and MAC, it's hard. I mean, ARP is a different protocol and the whole ARP, this is for both. This is dynamic.
It's a word using for the IP address. Dynamic word is using for IP addresses.
1 minute.
Not for the physical address.
No.
Because
Wait. I'll tell you. See, this is the IP address and this is the MAC address. What is this type? The ARP entry type is static and dynamic. It is not something, see, this is both values being used here. Your understanding is wrong, I would say. In my experience, I would say this is a type for the ARP, not for the IP or MAC address.
All right.
Yeah. That's, I mean, I want to give you the correct answer, right? That's the reason I'm telling. For this is an ARP type, dynamic or static. This is static.
Right.
Your IP address is dynamic or static. It could be either your static or dynamic, right?
Right.
So that based on the protocol. This is based on ARP because we are trying to fetch the detail for ARP. Because they ask a question, so ARP is a static or dynamic, you would say, yeah, this is a static entry or dynamic entry. This is because I did a ARP request. For this ARP request, I got this reply. So this is dynamic. This is going to change. This is not going to be this forever. If I change the IP address, it's going to change. This is all the static, right? Because see, this is a broadcast.
Yeah.
Always same. And this is static. Because this is never going to change. For this broadcast, this is for all layer 2 broadcast and this is layer 3 broadcast. Agree? Because this is 192.168.0.255. So this is going to be static because this is never going to change in this network. So this is most into the type of ARP. So the type of ARP is dynamic and static. Yeah.
What is the 0xLC and 0x18? It's a MAC address.
Where is it?
On the in 0.38 on the side of 192 interface 192.168.0.38 and 3 dots and 0x
Where is it? I don't find it. Sorry, is it you're talking about the output in my command prompt?
This one, yes.
This one?
Yeah, this one. Yeah.
I have to check on this. I think this is ether type, I believe.
Then what about for 10.1.1.1? It's also ether type.
I believe it looks like an ether type, because I have to check on that, because I'm not very concrete about that. I'm just speculating it could be a ether type, because ether type would be something like 0x11. I have to check on this. I'll give answers tomorrow.
No issue. Note your own notebook. Yes.
Okay.
Okay, sir. Thank you. Thank you, sir.
No problem. No problem.
Good night, sir.
Yeah, good night, guys. Okay, guys, good night.
Thank you, sir.
Have a great day. Bye then. Yeah, we'll meet tomorrow. We'll come up with a lab in EVNG. Same hour. Yeah, bye.